Hi guys, welcome back to 12.6 quadratic functions. We're going to start our reading right here, third paragraph. The function h equals negative 16 t squared plus 32t plus 3 is a quadratic function. A quadratic function is an equation in two variables that can be written in the form y is equal to ax squared plus bx plus c. All that means, I'm going to move my book over, make sure you are following along with your textbook. What that means is a quadratic function, is anything in the form of ax squared plus bx plus c, where a, b, and c represent any whole number, so 1, 2, 3, they're just your standard coefficient, or not, yes, coefficients. They're just your numbers in front of your variables. What makes something a quadratic, though, is the presence of this exponent. Any polynomial raised to a power of 2 is considered to be a quadratic function. So, example 1. We're told to make a table of the values for the quadratic function. So, example 1. We are told to make a table of values for this following quadratic. Y is equal to 2x squared plus 3x plus 1. Again, we know that this following expression, I'm going to move my book so you can mostly see my notes. We know this following expression is a quadratic because it is an expression or a polynomial being raised to a power of 2. That's what makes it a quadratic. But now we're told to make a table of values. And the way we're going to do this problem is we're going to do it the way we used to in 6th grade math for solving graphs. We create a table of values and we plug in these values for x. Once we plug in these values for x, we generate a y, and we're going to have a set of ordered pair. So our book tells us to do -2 all the way through +2. So we're going to have a set of x values that we're going to substitute into our equation, which is 2x squared plus 3x plus 1. When that's done, we will have a set of y values, and then we will have our ordered pair, and then we would be able to graph this quadratic. So this is just what our table looks like. And starting with -2, we're going to say let x equal -2, and when x is -2, what is y? So 2 times -2 squared plus 3 times -2 plus 1. -2 squared is +4. 4 times 2 is 8. So now 8 plus 6 times -2 is -6. So 8 plus -6 is +2. +2 plus 1 is 3. So when x is -2, our y value is 3. And we're going to repeat this process. So we're going to say when x is -1, what is y? Plug it back in for each of your x values. 2 times -1 squared plus 3 times -1 plus 1. -1 squared is +1. +1 times 2 is 2. 2 plus 3 times -1 is -3. So 2 plus -3 is -1. -1 plus 1 is 0. So when x is -1, y is 0. And we're going to keep going. Our next value is 0. 2 times 0 squared plus 3 times 0 plus 1. 0 squared is 0, 2 times 0 is 0. 0 plus 3 times 0, 3 times 0 is 0, so 0 plus 0. 0 plus 0 plus 1, 0 plus 1 is 1. So when x is 0, y is 1. And we're going to keep going. Our next value is positive 1. So 2 times positive 1 squared plus 3 times positive 1 plus 1. 1 squared is 1. 2 times 1 is 2. 2 plus 3 times 1. 3 times 1 is 3. So 2 plus 3 is 5. 5 plus 1 is 6. So when x is 1, y is 6. And now we have one last value, 2. 2 times 2 squared plus 3 times 2 plus 1. 2 squared is 4. 4 times 2 is 8. 8 plus 2 times 3 is 6. So 8 plus 6 is 12. 12 plus 1 is 13. Although I think I just made a mistake there. Hold on one more second. 2 squared is 4. 4 times 2 is 8. 8 plus 6, there we go, is 14. 14 plus 1 is 15. And so now we have ordered pair. We have negative 2 comma 3, negative 1 comma 0, 0 comma 1, 1 comma 6, 2 comma 15. We have created a table of values that tell us how to graph this particular quadratic function. And then we have two boxes. They say for x equals negative 2, the process of substituting and simplifying is shown, so just in your textbook. And then when x equals negative 1, 0, 2, 1, and 2, only the substitution is shown. So they're just saying in your textbook they broke down the first one for you, and then they just did the substitution and gave you the answers. So that's example 1. Example 2 and onward. So it's great that we've now come up with our values, but next it's going to ask us, well, what do you do to graph it? What is a graph of this quadratic? And remember, a quadratic is any polynomial raised to a power of 2. So graphing quadratic equations, top of 680. The graph of a quadratic function is a U-shaped curve called a parabola. The quadratic function is an example of a non-linear function. A non-linear function is a function whose graph is not a line. So we're just told two things. We are told the vocab word of a parabola, and a parabola equals a U-shaped graph and now this is in direct contrast to our linear equations. So far, every time we've graphed something, we've graphed a coordinate plane, right, where we plug in these points and we get these beautiful lines, just like that. However, they're saying a quadratic graphs as a parabola, which is a U shape. So rather than it being a straight line, it's going to look something like this. And now they're saying a parabola is an example of a non-linear function. Well, linear means line, so the fact that it's a non-linear function just means it's not going to graph in a straight line anymore, and that's okay. So if we look at example 2, they're going to ask us to graph a particular quadratic function. So example number 2, we have the function y is equal to 1/2 x squared plus 1. Remember we said a quadratic is ax squared plus bx plus c? Well, we clearly see where we have our ax squared, but we're missing our bx. Remember, b can be any number. That includes 0. So in this particular function, we really have 0 times x, which just kind of cancels out. So it got canceled out, so we're left with ax squared plus c. So step 1 is we're going to make a table of values. We're going to have our x's, what we're plugging it into, which is 1/2 x squared plus 1. Then we're going to get our y values, and that's going to give us our ordered pair. And your book uses the values -4, -2, 0, 2, 4. So we're going to do the same thing. So starting with -4, we have 1/2 times -4 squared plus 1. -4 squared is positive 16. Half of positive 16 is 8. 8 plus 1 is 9. So when x is -4, y is 9. Next we'll do -2. So 1/2 of -2 squared plus 1. -2 squared is positive 4. Half of positive 4 is 2. 2 plus 1 is 3. So when x is -2, y is 3. Repeat. Now we have 0. 1/2 times 0 squared plus 1. 0 squared is just 0. 1/2 times 0 is 0. 0 plus 1 is a positive 1. 2 more values. We have positive 2. 1/2 times 2 squared plus positive 1. 2 squared is 4. Half of 4 is 2. 2 plus 1 is 3. Last value is 4. 1/2 times 4 squared plus 1. 4 squared is 16. Half of 16 is 8. 8 plus 1 is 9. Notice what we have here. We have a mirror of x values with opposite signs, -4, 4, -2, 2, with 0 as our middle point. So these ones are mirrored with opposite signs. But if we look at our y values, they're perfectly mirrored as well, including the same sign. And this is a pattern you'll see if you include your midpoint of your graph. You end up with 9, 9, 3, 3, and 1 being your middle point. So now we're asked to graph this parabola. So using just an index card that I have folded in half, I am going to graph this. Just going to draw a straight line down. Because I have to go up to 9, I'm going to make it really low. And it's going to look like this. Boom. Alright, so 1, 2, 3, 4. And then -1, -2, -3, -4. Just creating my boundary point so I know where I'm looking. So I have -4, positive 9. And of course I put my boundary point on the wrong spot. That's -4. 1, 2, 3, 4. But -4, 9. So we counted over to 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our first point goes right there. Next we have -2, positive 3. 1, 2, up 3. 1, 2, 3. And our next point is there. Then we have 0, 1. So when x is 0, y is 1. There's our middle value. Next we have positive 2, 3. So 1, 2, up 3. 1, 2, 3. There's our value. Then we have 4, 9. So over 4 on x. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my value. So now you can start to see the beginning of my U shape. And now you're just going to go in, curve out your bottom, and connect your points. And congratulations, you've graphed your first parabola. Example 3, graphing a quadratic function. So this is just, again, another one of our previous. So we're going to flip the page onto example 3. This time we have a new quadratic. So example number 3. And we're told we have the quadratic function y is equal to -x squared plus 2x minus 1. And your book gives us the values -2, -1, 0, 1, 2, 3 for x. So our x values, then we have -x squared plus 2x minus 1, and that's going to produce our y values. Boom. All right, so starting with -2. When x is -2. And now this is super important. This negative sign exists before we do anything to our negatives, or not to our negatives, to our x values, so we have to include it. We have a -2 squared plus 2 times -2 minus 1. So this problem is just tricky because of all of your sign work, and you just have to be super careful to follow your signs. So -2 squared is +4. But then you have this pre-existing negative sign, or -1, that you have to multiply whatever the inside product is. So we had a +4 times -1, so we're going to have -4. -4 plus 2 times -2 is -4, so -4 plus -4 is -8. -8 minus 1 is going to be -9. So again, this problem is a lot of the same. However, you have to be careful with your signs. Next, we have -1, so -1 squared plus 2 times -1 minus 1. -1 squared is +1. +1 times -1 is -1. -1 plus -2 is -3. -3 minus 1 is -4. Continuing on, we have 0. We always love when we have 0 because 0 is the easiest. 0 squared is 0, plus 2 times 0 is 0, so it's just -1. Easy peasy. Now we have +1, so -1 squared plus 2 times 1 minus 1. So 1 squared is 1, 1 times -1 is -1, -1 plus 2 times 1 is 2, so -1 plus 2 is 1. 1 minus 1 is 0. Two more points. -2 squared plus 2 times 2 minus 1. 2 squared is 4, making a -4. -4 plus 4 is 0. 0 minus 1 is -1. And then the last value they give us is 3. -3 squared plus 2 times 3 minus 1. So we have 3 squared is 9, make it a -9. -9 plus 6 is 3. Or -3, sorry. -3 minus 1 is going to be -4. And so just like I said before, we end up with these perfectly mirrored values, with the exception of this 9, whereas if we continue one more value, we will get that 9. However, we're going to stop here. So this 9 would be mirrored if we went one more, but we're just calling it because we have enough values. But we have -4, -4, -1, -1, 0. And we know that 0 is going to be the middle point of our graph. So now we're going to go ahead and graph it using my trusty straight edge. But this time our values are negative. We have a -9y. So I'm going to kind of draw it opposite from how I did last time. And make it long on the bottom and shorter up top for my graph. And so for my first value, I have -2, -9. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my first value. Then I have -1, -4. -1. Now 1, 2, 3, 4. I have my second value. Third value, I have x is 0, y is -1. So there's my third value. My fourth value, I have 1, 0, so x is 1, y is 0 right there. Then I have 2, -1, so x is 2, y is -1. And lastly, I have 3, -4. So 1, 2, 3, down to -4. And boom. You can see again that if I were to fold it down the middle, along my middle value here, right when you start to see your sets of repeating numbers, boom, 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 that becomes my line of symmetry. That if I fold my paper right down that middle, my parabola would be perfectly matched on both sides. And now you just, again, you curve out the bottom and turn it into your U-shaped graph, connecting all of your points and including your arrows. All right. On to the next page, 681. This is going to talk about something called maximum and minimum values. Your maximum and minimum values are just the highest or lowest points on your graph. So for example, you can see that this point right here is where my graph turns. I'm going up, 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 and once I get to this point right here, which is 1, 0, my graph starts to go downhill. It's my middle value. But in addition to being my middle value, it's also my highest point. It's the top of this mountain. I started all the way down here and I climbed it all the way to here, and this is the maximum value before I start going down. Comparatively, on the first one we graphed, we started really high and we walked all the way down this mountain until we hit this middle point, which was 0, +1. And that's the absolute lowest point on my graph before I start coming up. It's my minimum value right here. And that's what we're talking about. We're talking about identifying your minimum and your maximum of your graph. If it's an upside down U like this, you have a maximum value. If it's your normal U, you have a minimum value, your lowest point. So on 681, maximum and minimum values. In the quadratic function, y is equal to ax squared plus bx plus c. The value of a indicates whether or not the graph will open upwards or downwards. So again, we have our standard formula for quadratic, which is ax squared plus bx plus c. And now they're saying the value of a will tell you whether or not your quadratic opens up or down. What they really mean is the sign of a. If a is positive, it's going to open upwards like that, like a normal U. However, if a is negative, it's going to open downwards like an upside down U. Look at example 3, for example. We had, example 3, we had negative x squared. Negative x squared, if it's negative, it's opening down. Example 2, we had a positive 1/2 x. If it's positive, it opens upwards. So it's not necessarily the value of a, but the sign of a. Positive opens up, it's smiling. If it's positive, it smiles upward. If it's negative, it's sad, it's frowning because it's negative. All right. When a squared is greater than 0, as in example 2, the graph of the function opens upwards. In this case, the function has a minimum value. So again, if you're opening upwards, you're smiling, you have a minimum value. You have the lowest point of your graph, which is the y-coordinate of the lowest point on the graph. I'll explain that in 1 second. When a is greater than 0, as in example 3, the graph of the function opens downward. So when it's negative, it opens downward like a frown. In this case, the function has a maximum value. So it has the highest point. When it's opening downwards, it has a maximum value, which is going to be the highest point on your graph, which is the y-coordinate of the highest point on the graph. So if we were to say what is the minimum and maximum value of our graphs in example 2 and 3, They just said it is the y coordinate of the highest or lowest point. So if in example 3, we said this was our highest point, this was our highest value, and we said it was at 1, 0. And what we just said was the minimum value is whatever the y coordinate is of your minimum or maximum value. So if this is our maximum value, max value is at 1, 0. But we said it's the y value of it. Our y value of this graph is 0. So our maximum value is y equals 0. On our previous one, we have a positive 1/2, which means it's opening upward. If it's opening upward, it has a smile, so we're looking at the lowest point of our graph. We said right here was our lowest point. The lowest point of our graph was 0, 1. So our minimum value was found at 0, 1. But we only look at our y value. If we were to state our minimum value is y equals 1. When y equals 1, that is the lowest point on our graph. That is all that means. So let's look at checkpoints 10 through 12 together, and we'll just state them. So if it is a positive A, it opens upward. So let's see. If it's a positive A, it opens up like a smile. That means it has a minimum point. If we have a negative A value, that means we have a frown face. It opens downward, and because of that, we have a maximum value. We have the highest point, and we have just one. We have a max value. So now if we're looking at checkpoints 10, 11, and 12, all it's asking is to state whether or not it has a minimum and maximum. So question 10, our A value is 4.5. 4.5 is positive, so therefore it's going to open up like a normal smiley face. Because it's opening upwards, it has a minimum value. Number 11, we have an A value of x squared. There's always a hidden 1 in front of it. So we have positive 1x squared. Because 1 is positive, it's opening upwards like a normal smiley face, which means we have a minimum value. And lastly, for number 12, we have negative 3x squared. Because our A value is negative, we're frowning, we're opening down. Because we're opening down, we have a maximum value. All right, good work, guys. I know that lesson was long, but thanks for sticking in it. Bye.